Hi, Sam Begg here. I'm continuing on with my presentations on three-dimensional 3D objects. Today is going to be part 4 and the first lot of quiz questions we're going to go over. So it's going to be some more worked examples. Here's a reminder again of some 3D objects. A cylinder, a cone, a cube, a sphere, pyramid and a prism. Before we go on to the worked examples, there's some two-dimensional properties that are important to remember. In this case, I want you to remember what the diameter and the radius relationship is. Radius, you'll remember, is the size from the center of the circle to the edge of the circle, any position all around the edge of the circle. In this case, it's 20 centimeters. Now, if the radius is 20 centimeters, then the diameter is 40 centimeters. So diameter is twice the radius is half the diameter. Remember that for some of the quiz questions that are coming up. Another thing to remember is the area of all right-angled triangles, whether they are isosceles right-angled triangles or scalene right-angled triangles. And the area for all right-angled triangles is a half the breadth times the height. So there's the breadth and there's the height. Remember that one as well. Here's a reminder of the volume formula. So first object is a cube. Can you remember the volume formula for a cube? Yeah, it's A cubed. So A times A times A. What's this shape? Yeah, it's a cuboid. The volume formula for a cuboid is length times width times height. Length times width times height. What's this shape? Yeah, it's a triangular prism. So it's a prism with a triangular shape at the end. And the volume formula for a triangular prism is a half width times height times length. So width of the triangle, height of the triangular cross section, and length of the prism. What's this shape? Can you remember this one? It's a trapezoidal prism. It's a prism with a trapezoidal cross section. And the volume formula for a trapezoidal prism is a half times B1 plus B2 times H times L, the height and the length. B1 plus B2 times H for height times L for length of the prism. Next shape is a pyramid. In this case, it's a square-based pyramid. So the volume for a pyramid would be 1/3 times the area of the base times the height. In this example here, 1/3 times a squared times height is a squared because the base of the pyramid is a square. So it would be 1/3 times 4 squared for a squared. We've got 4 by 4 times 5 for the height. 1/3 times 4 squared times 5. Next shape is a pyramid with a triangular base. The formula for volume for a pyramid is 1/3 times the area of the base times the height. So with this being a triangular based pyramid, the formula would be 1/3 times half times length times width. Remember, I said to remind yourself of the 2D formula, and this is the 2D formula for the area of a triangular. You're looking for the area of the base. In this case, it's a triangle. So the area of the base would be the area of a triangle, which is a half times length times width. So the volume formula for a triangular based pyramid is 1/3 times half times length times width times height. If you would put it in these values into the formula, it would be 1/3 times half times 13 times 9 times 16. So length is 13, width is 9, and the height is 16. So 1/3 times a half times 13 times 9 times 16. Next shape is a cylinder. Volume formula for a cylinder is pi r squared h. Next shape is a cone. Volume formula is 1/3 times pi r squared h. And the last shape is a sphere. The volume formula for a sphere is 4/3 times pi r cubed. Let's have a look at some quiz questions. The first quiz question is going to be on a cuboid. Remember, volume formula for cuboid, length times width times height, which we abbreviate to L times W times H. So this one here, let's input these values into this formula. So L, 10 centimeters, W, width, 4 centimeters, H, height, 3 centimeters. 10 times 4 times 3. Simplify it, 40 times 3, result 120 centimeters cubed, or 120 cubic centimeters. Whichever way you like to say it, it's correct both ways. Second example is a cylinder. Volume formula for a cylinder, pi r squared h. So if we transfer these values into the volume formula, now you'll see we don't actually have r explicitly expressed. We don't have the radius, but we've got the diameter. If you remember, towards the start of the presentation, we said that the radius was half the diameter. So we have pi, 3.14 to 2 decimal places, and then we have r squared, which we're going to express as d divided by 2 squared. So d for diameter is 12. So 12 divided by 2 squared times h, 5. So simplifying that, 3.14 or pi to 2 decimal places times 6. 12 divided by 2 is 6 squared times 5. 3.14 times 36 times 5, which equals 565.2 centimeters cubed to 2 decimal places for pi. Remember, it's important you state how many decimal places of pi that you've used. Question 3. A pyramid. A reminder, the volume formula for a pyramid, 1/3 times area of base times height. So what shape is the base for this pyramid? Yeah, it's a square. This is a square-based pyramid. So the area of the base is going to be the area of a square. Now here's the example we're going to do. We're going to have a square with 8 centimeter sides and 10 centimeter height. Let's put those values into our volume formula. So volume formula, 1/3 times the area of the base times the height. So we know that the area of the base is a squared because it's a square. So 1/3 times 8 squared times 10 for the height. 1/3 times 64, because that's 8 squared, times 10 equals 213.33 recurring centimeters cubed. Question 4 is going to be based on a cone. The volume formula for a cone is 1/3 times pi r squared h. Here's our example. Now don't be thrown by the fact that the cone is upside down. The formula and the dimensions and how you use them is the exact same irrespective of the orientation of the cone. So cone formula, 1/3 times pi r squared h. Let's input those values. So 1/3 times pi, 3.14 to 2 decimal places, times 6 squared. We've got radius of 6 squared r squared times 15 for the height. Start to simplify that. 1/3 times 3.14 times 36 times 15. And that equals 565.2 meters cubed, pi to 2 decimal places. Question 5 is going to be based on a sphere. Volume formula for a sphere, 4/3 times pi r cubed. Here's the sphere that we're going to do the question based on. Here's a reminder of our volume formula for a sphere, 4/3 times pi r cubed. Again, you'll notice we don't actually have r in this particular example, but we have d. We've got diameter. We don't have the radius, but we've got the diameter, and obviously we can get the radius from the diameter. Yeah, so this is how we're going to do it. Diameter divided by 2, because r is diameter divided by 2. Let's input those values. So 4/3 times pi, 3.14 to 2 decimal places, 12 divided by 2 to give our radius, and that's going to be cubed. So 4/3 times 3.14 times 6 cubed. 4/3 times 3.14 times 216, and that equals 904.32 millimeters cubed with pi to 2 decimal places. Question 6 is going to be based on a trapezoidal prism. The volume for the trapezoidal prism, remember, is 1/2 times B1 plus B2 times H times L. This is the example we're going to use. So in this worked example here, what is B1? So here's our template, B1 at the top. So B1 is this size here, and we get it from the size of the opposite side. So B1 in this example is going to be 9 centimeters. Next variable we need to know is B2. So B2 is the length at the bottom. We've got the length at the bottom over here, so it's going to be 13 centimeters. Next variable we need is the height, h. So h is here in our template, h is here 7 centimeters in our actual worked example. So h is 7 centimeters. And that leaves us with L. What's L? L in our template here is the length of the prism. Over here it's 20 centimeters. So here's all our variables. B1, 9, B2, 13, H, 7, L, 20. Let's put them into our formula. So we have a half times B1 plus B2 times H times L. B1 is 9, B2 13, H 7, L 20. Odd mass applies, so let's do the things in the brackets first. So 13 plus 9 is 22. Half times 22 times 7 times 20 equals 1,540 centimeters cubed. Now, let's consider that you don't have, or you've forgotten, the volume formula for a trapezoidal prism. Is there an alternative way that you could have done question 6 to end up with the same answer? So the alternative way is to break down this trapezoidal prism into 3 separate 3D objects. So which 3 3D objects make up this shape? So if you break down this shape into its constituent parts, you would have 2 triangular prisms plus 1 cuboid. So let's first find out what the volume would be for the triangular prisms that make up this trapezoidal prism. Remember, volume for a triangular prism is the area of the cross section times the length. Area of the cross section for a triangle would be a half times width times height times length. So here's our trapezoid at the end of the trapezoidal prism. Now what we want to know is what are the dimensions of the triangles, so that we can work out the volume of the triangular prisms, 2 of them, and then add that to the volume of the cuboid in the middle. So here's our 2 triangles, right angled triangles at the edge. We know that B1, the top of the trapezium, is 9 centimeters. We know that at the bottom, B2 for the trapezoid is 13 centimeters. And we know that H for the trapezium is 7 centimeters. So far we've got 7 centimeters for our triangles, but we don't know this size here yet. So this is what we need to work out. So that we can work out the volume of the triangular prisms, we need to know this size here. It'll be the same size on both sides. So the way that we're going to work that out is B2 size minus the B1 size, and then divide that by 2. So 13 minus 9 is 4, and you divide it by 2 to get 2. So the size of the bottom of the triangle for the triangular based prisms is 2 centimeters. So for the triangular prism, remember volume formula, half times width times height times length. Now we've got the width and the height for our triangle. So the area of the triangle for the triangular prism, 13 minus 9 divided by 2, height 7, length 20. So half times 4 divided by 2 times 7 times 20, half times 2 times 7 times 20, that equals 140 centimeters cubed. So that's the volume for one of the triangular prisms. But in this trapezoidal prism, there are 2 triangular prisms. So the volume of the 2 triangular prisms that are constitute parts of this trapezoidal prism is 2 times 140, which is 280 centimeters cubed. So that's worked out the volume for the 2 triangular prisms. Now in the middle we've got a cuboid, and the volume for the cuboid would be length times width times height. So length 20 centimeters, width 9 centimeters, because this is the cuboid we're going to work out now. So the width of the cuboid is 9 centimeters and the height is 7 centimeters. So the volume of the cuboid, which we're going to add to the volume of the 2 trapezoidal triangular prisms, is 20 times 9 times 7. And that equals 1260 centimeters cubed. So we now have the volume of the 2 triangular prisms and the volume of the 1 cuboid. So we can add those values together. So we've got 280 centimeters cubed, which was the volume of the 2 triangular prisms, plus 1260, which is the volume of the cuboid, which equals 1540 centimeters cubed, which was the exact same value when we worked out just using the trapezoidal prism volume formula. Now, as you'll see, the alternative method is a lot longer and a lot more difficult, but there are ways to do it if you forget and if you're not provided with the volume formula for the trapezoidal prism. You can break it down into constituent parts. Thanks very much for listening. As always, any feedback, queries, comments, inquiries in the comments section below. Thanks again.